Good morning, everyone. My name is Melanie Walling, and this is going to be a short presentation. I'm going to just show you real quick on the source model that we use for the hazard sensitivity, which I'll be showing in two more after Bob's presentation in about 20 minutes. So just a little background on the source model that was used in the hazard sensitivity for workshop 3 is that first, for the audience out there, is that it does not reflect the PVNGS source model. So the source model that we used in this hazard sensitivity will not be used for the PVNGS. It was selected because it was simple source model. It's a modified source model of what was run in the past, and it was selected to capture the general trends tested in the hazard sensitivity. So what was important in the hazard sensitivity, and I just took this most simple model. The sensitivity that I'll be showing in my next presentation, for which this source model was selected, was a sensitivity for the GMPEs to the local source effects, to the distance source effects, and to the path source effects. And you can see here the distance cutoffs for the local and the distance, and for the path we broke it up into north sources versus south distant sources. So a little background is that these are the fault sources run for the hazard sensitivity. There were over 30 faults, and for the Shack 2 hazard, the main fault contributor was the CR Pareto fault, which you can see is right here, and then here's the Palo Verde site. And so this was our main fault contributor. For the background sources, I chose the fine zonation sources to run for hazard. There were 11 fine zonation sources. What distinguishes these sources are the uniform rate of earthquakes. So there are no variable seismicity here that I ran. And you can see here that this is the host, this is the host source, this is the Sonoran Basin and Range, and this is the main source contributor at the high frequencies. And there's your site as is shown as a star as red. So to get the sensitivity for the local sources, and I should say local meaning the effects within 200 kilometers of the site, what was done was that it looked at the hazard contributed from what's shown in, what's highlighted as a dark circle. So the radius of that circle is 200 kilometers, and there were 4 sources that fell within that site. So I ran the hazard using these 4 sources for the first 200 kilometers when I was performing the hazard sensitivity of the local sources. The hazard sensitivity for the distant sources is the opposite. All the background fine zonation sources fell within it, as well as the faults. The faults are not shown here, but the faults were actually included in the hazard sensitivity. And for the distant sources, I only looked at the hazard from 200 to 400 kilometers. So the sensitivity that we'll be seeing later is running this model where the sources were run from 200 to 400 kilometers, and then they were matched with the base case between 0 and 200 kilometers. And I'll talk more about that in my next presentation. For path effects, we only looked at distant sources, and we broke it up into the northern section shown here. Like I said, faults are not shown here, but were included. And so we looked at how did the GMPEs contribute to the hazard just for those northern sources shown, including faults. For the southern distant sources, we did the same, and we looked at those sources shown in a highlighted here. And also, just to let you know that the base case ground motion prediction equations that were used in the hazard sensitivity that I'll be showing are the 5 NGA West 1 ground motion prediction equations, equally weighted with a BS30 of 760. And I believe that's it for my source model. that I selected. Any questions? Because so Yusuf asked why NGA West 1, because that's what I was instructed. Any other questions?
I think we can answer that for you. We're trying to use the same base case that we've been using before. So we're just going to have a common base number so we see how things change.
So were the 2008 models, was there an anelastic attenuation term put on those? Because they weren't valid out to beyond, say, 200 kilometers.
No, they are the 2008
But
from.
you'll see the new models compared to that. That's not all we had to define something as our reference. And what we showed you the last few times was NGA West 1. And so we're keeping that as the same reference.
Okay.
And then bringing the new models in.
Oh, all right, all right.
Other questions? All right, I give the mic to Bob.